would like to play the video. And the second one, maybe after the first two, you can, if you are busy with other things, that's fine. Afterwards, I think most of the people are going to present live.
Okay, I think you are.
Oh, actually, I can see it now.
Okay, perfect.
I don't know, is it activated?
Yeah, I can also see it.
Awesome.
Great. Wait.
I can see the two videos there. I can also play.
Okay, perfect.
Awesome. Thank you so much.
No, you're welcome. I'm happy to help.
Thank you so much. Yeah, being giving us great help. All right. So it seems that the technical issues has been resolved, and we are able to proceed our sessions without problem. Keep fingers crossed in the coming hour. So in this session, this is the last session for our poster track. And we have 6 papers, very exciting topics to write on. And as the presenter of the posters, I would also hope to encourage you to ask questions to the other presenters, because after a 5 minutes presentation, we'll have 3 minutes of discussion time for each work. All right. So yeah, the first work we're going to have is presented by Ya Xiao. The title is Comprehensive Comparison of Embedding Approaches for Cryptographic API Completion. And yeah, so you can proceed with the videos.
Title is Comprehensive Comparison
Thank you very much for the presentation. So we are open the floor to the discussions. If the audience from have any questions to Ya, she is here to discuss with you. Let me monitor the chat.
So I have a question.
Go ahead.
You said that you want to do in your future work extend to more general code. What do you mean especially by general code? Can you go deeper on that?
Okay, that is a good question. Like in the current study, we try many different embedding approaches. However, when evaluate them, we only use some cryptographic related code. So that is means like maybe in the future work, we can just use all kind of code and even maybe different languages like Python, Java, like C, and to test the embedding effect.
Okay, thank you.
Thank you.
Actually, I have a related question to that. At the beginning, during introduction, you mentioned that the cryptographic APIs are different. They are harder to use. So what kind of difficulties is caused by this kind of APIs compared to traditional API libraries?
I think there are some like related studies. They reported that when developers use some cryptographic APIs because they don't have sufficient security knowledge, so that they often like make some mistakes. Like for example, when you need to use some random number which is extremely strong, but they just use some ordinary random, and also maybe like when you need to generate a key, you need to call some specific key generation processed APIs, but some developers just directly hard-coded something like key equals to like a string and transfer it into some byte code format like that.
So do you envision that this kind of learning-based method can have the safety implications to the people who are adopting it, because the consequences might be high, right?
Yes, we think like if we could feed the neural network with all the like secure code, and if we show that the neural network is able to predict the API with a high accuracy, and that maybe this kind of application can be used for like suggesting correct options for developers.
Yeah. Thank you very much. Any other questions from the audience? Okay, so let's move on to our second presentation of today's session. It's from James Kellen, and the title of the work is Improving Responsiveness of Android Activity Navigation via Generic Improvement. So go ahead.
Hi, yeah, I'm James Cullen. I'm a PhD student at University College London, and I'm here to present my work improving responsiveness of Android activity navigation via genetic improvement. This work was completed in collaboration with my PhD supervisor, Justina Petka. So first, why did we choose to improve the navigation of Android apps? Well, we've got 3 papers here that kind of discuss the importance of responsiveness to users. So 1/3 of cases, when users would uninstall an app, it was because, well, poor responsiveness was at least part of the reason. 59% of bad reviews mentioned responsiveness, and delays of over a second will make users unhappy. So we can see that this is something that is important to users and something that we want to improve. So what specifically is navigation responsiveness? Well, to start with, we need to talk about general responsiveness. In general, an app is responsive if there's a minimal delay between a user interacting with the UI and the UI updating to reflect that interaction. We also need to talk about activities in Android. So these are the main UI components of an app, the kind of the screens that a user interacts with. And they have these sets of callback methods that define how the app will behave when it launches, when it shuts down, and a few other things. But primarily, and for us, the thing we're interested in is these callback methods will get called when you move from one activity to another. So the activity that you're on will get shut down and you want to be loaded up. So we define navigation responsiveness as minimal delays when moving between these activities, and we also see that the execution time of these callback methods is going to impact this responsiveness. So the lower the execution time, the better the navigation responsiveness. So we want to optimize this responsiveness, and we choose to use genetic improvement. So GI is a technique for automatically improving software. In the past, it's been used to fix bugs, reduce execution time, reduce memory usage, and a few other things as well. So at the core of GI are meta-heuristics or heuristics that are used to explore a landscape of these versions of software. So this can be something like genetic programming or local search. Each version is defined by a list of edits. In our case, we used edits that act on statements. So they can swap two statements around, replace one statement with another, delete a statement, or copy a statement from one location to another in the source code. Once we have our new versions of code, we can validate them with the tests of the project. So we can run all of the tests that cover the modified class or methods and see if it passes, we can say that this passage is valid. We can also use test executions to measure the property that's been improved. So you can measure the execution time of a test case if you're improving execution time. And then you can use this as a fitness value to guide search towards more optimal variants. And it's kind of an iterative process of generating new variants, measuring their fitness, and trying to move through the shared space to better versions of code. So in our work, we target the execution time of the callback methods of the activities, which are called during navigation, and we use genetic improvement to try and optimize them. Okay, so one of the probably most difficult parts of this work was getting some benchmarks to test out our approach on. We needed apps that were well tested, and particularly the activities had to be tested because we wanted to modify them and be confident that any broken versions of the application would be caught by the test suite. We also decided to use the Roboelectric testing library. So this is a library that essentially allows you to do UI testing without having to use an emulator or device and the costs associated with that, like installing the app. We also chose to go with apps written in Java rather than also including Kotlin. This was a combination of the GI tool that we use currently works certainly on Java code, and also is the more popular of the two languages for Android development. So we checked every single app in the F-Droid repository, which is a big repository of around 3,000 apps that are all open source. And first we filtered by those that use the Roboelectric library. And then once we had that set, we checked the branch coverage of each of them on their activities, and we found that only 7 apps, unfortunately, were suitable for this. So it's quite hard to find apps for this approach at the minute. But if we look at our results, so we modified the GIN tool, which is a pretty common tool used in GI. We did 20 runs on each benchmark, and we see some summary statistics. You can see that we found improvements of up to 30% for one app. So this is the CPU time of these callback methods, which is kind of a proxy for navigation responsiveness. So that is positive. And in that patch, the best patch, which achieved that 30% improvement, it removed a condition, an if statement, which checked if the app had been launched from the command line. So it's a real edge case that your average user is really never going to encounter. So it kind of presents this opportunity for a trade-off that a developer could decide whether or not this check is this very check that's never going to be triggered is worth the 30% reduction in navigation responsiveness. So in summary, genetic improvement is able to find improvements to this navigation responsiveness of up to 30% in all of the apps that we tested. Right now, unfortunately, apps really aren't very well tested. Just to put it into perspective, I think over half of open source Android apps have no tests at all. And from my experience of measuring branch coverage, those that do have tests tend to have very low branch coverage. So if we could get more tests, we could obviously apply our approach on a much wider set of benchmarks and really evaluate it. And also, as we saw, some trade-offs can be found between functionality and responsiveness. So this approach would probably benefit when used in along with a very strong code review system where developers could kind of leverage these trade-offs and try to find the best versions of software. Okay, so that's the end of the presentation. I look forward to many questions that you have.
Yeah, if you have any questions, feel free to speak up or type in the chat.
I have a question. So yeah, I see that you can see like a performance based on what you did in your method, like an improvement in terms of responsiveness. Do you plan to do something with like users to see if they can perceive this difference in the future?
Yeah, that would be definitely something that was interesting. So we have actually evaluated these patches ourselves, especially the best ones. There is a noticeable difference. So in terms of like the absolute time, it goes from like the best one goes from like 1.1 seconds to 0.9 seconds. So that's kind of the threshold at which it is kind of annoying. So I think the improvement is visible in these cases. For some of the smaller ones, maybe not. But yeah, I do think that's an interesting thing to look into.
Any questions? Yeah, so maybe I have a small question related to what the question asked earlier. Is if you think about users, it's probably also related to what kind of functions they're navigating, what kind of progress they're interacting with the app that might influence how they perceive the responsiveness. Do you think that when on the performance issues that bottlenecks you observe, do you think that the functions and their perception can relate to users? Are there any associations there?
Yeah, I think like these are kind of probably the parts of the applications where the users might expect the most delays, because like moving between like one screen and a completely different screen rather than just opening a menu or typing in a box or whatever. So maybe there is a bit more tolerance there, but it's also is probably where the biggest delays are present. So might also be a reason to really target them.
Right. Thanks very much for the talk. Yeah, I think that let's move on since we have still 4 talks to go with, and by after we go over all the talks, we have some remaining time so we can open the floor and to do some open discussions. All right. So next one we have Stephen Rees, and the talk is titled "A Quick Repair Facility for Debugging." So Stephen, you're on. I think you're still muted.
Unmute, one of the things I have to set up. Share screen, have to shut up. Share. Go to the screen. Okay, thank you. Our goal is to make automatic program repair practical. To do this, we define a different problem, automatic program repair, as an offshoot of debugging. We assume the developer is in the debugger at a breakpoint, identifies a symptom of a potential bug, and then asks for suggested repairs. This is much like Quick Fix, except it handles semantic errors. Our tool, Rose, works for simple runtime errors and does automatic program repair without a test suite. The tool is designed to be practical and useful, producing results in seconds from within an IDE. It introduces innovative techniques for fault localization and repair validation that make use of the debugger, but do not require a test suite. The best introduction is to see Rose in action. Hello, and welcome to Code Bubbles. Today, I want to show you our new debugging assistant, Rose, which is available as a Code Bubbles plugin. Here I have a sample program that replaces the name of an animal with the name of its offspring. For simplicity, I created a test program that illustrates a bug. Let's run that test. As you can see, the program has stopped with an exception. And in this case, the exception is a null pointer exception. Now we can ask Rose to help us debug. We do this by right-clicking on the arrow annotation here and selecting Ask Rose to help debug. Rose pops up a bubble to get the information about the problem to be repaired. Because we stopped in an exception, it guesses the problem is the exception, which is correct. Now we can ask Rose to repair the program by clicking on Suggest Repairs. Rose responds with a window showing the suggestions. These are generated by a set of plugin components and based on code patterns and the results of code search. These have been validated by Rose and ordered so that the most likely repairs are first. The validation is done by simulating a partial run of the repaired program. The first 3 suggestions here are all correct. They avoid the null pointer exception appropriately. We can select the first and have Rose make that repair. You can see in the editor window, it has actually made the repair. We can now save that change and continue execution. Now the program works correctly, and Rose did the debugging for us. As noted, Rose uses a generate and validate approach based on debugging information. It makes use of a tool for flow analysis via abstract interpretation, FATE, for doing fault localization, and a tool for doing live programming in Java, CD, to generate traces for validation. ROSE takes a whole different approach to automatic program repair and works without the extensive test suite that is usually present. We needed to see if it worked. We did an evaluation of ROSE by looking at 2 sets of typical developer bugs, using Qwik's bugs for student programs and a subset of defects for J for more complex ones. For Qwik bugs, we repaired 40% more bugs than previous reports and did so with a total mean time of under 5 seconds, median time. This shows ROSE works for simple cases. For defects for J, we achieved close to the best reported results on the selected bugs, but did so in well under a minute compared to previously reported times of over 4 minutes. Moreover, the median time to find the correct repair was only 7 seconds. This shows that ROSE could be useful for real programs. Our conclusion is that a debugging approach to automatic program repair is both possible and practical. We have shown that it's possible to do automatic program repair without a test suite, and we have shown that it's possible to incorporate automatic program repair as a useful tool in an IDE. ROSE is available as open source on GitHub and is incorporated into the CodeBubbles IDE as a plugin. Please contact me for additional information. Thank you. Stop sharing.
Thank you for the talk and a great demo. So let's open the floor. Anybody have questions?
Yeah, I have a question. I was just wondering, you said that the repairs are based on some patterns. I was wondering where those patterns came from.
I looked it up. Went through various sources, typical code bugs, code smells, typical errors I had, the pattern-based automatic program repair facilities in the past, and looked at their patterns. So it's a variety of different patterns that are used. There are like 4 different actual plugins that use patterns there.
Thank you.
Yes, ROSE does work with Java programs.
So you also mentioned that the repair suggestion come from code search, right?
Right.
What is the scope of the search?
Pardon?
What is the scope of the search? Is it a web search or some specific resources?
GitHub.
Okay.
It's using SharpFix, which is a previous reported work on automatic program repair. We just it took that core and plugged it into this facility. We also have a version of Sequence R, I believe it is, a machine learning approach plugged in to generate things, but it generates too many false things that don't even compile. So we don't use it that much these days.
So Lavinia have a question. Work with Java program. Yes, I think that is Stephen have mentioned that this works for Java right now.
This works with the CodeBubbles Java facilities. It would work with Eclipse and IntelliJ IDE as well, but I don't have a front end for either of those. But the whole back end, the whole system would run there. The testing was all done using Eclipse. It was without a front end.
So I think it's a great effort to push this kind of tools closer to the developer. So do you consider later to do a user study to enrich the understanding about how the developers interact with the tool?
Oh, we're planning to do that this summer.
Awesome. All right, looking forward to
I don't know if the tool's robust enough or mature enough to do a real user study, but we'll do one anyway because it's required.
Yeah.
I come up with a related question that is about like the validation of the suggested repair. Because our group once did some research about the cryptographic vulnerabilities, and in such kind of work, we found that actually repair is more complicated than what we think. An example is that from the developer's perspective, like even we suggest a fix, for example, to repair a broken broken algorithm, like Cypher algorithm, into a more advanced one. But the developers often reject to do so because they would think that if they change the code in one place, for example, for encryption, they also need to change other places for decryption. Otherwise, like the entire system cannot work, and lots of such kind of consistent issues. So I wonder that is ROS capable to like consider such kind of issues in the real world repair?
Well, the tool here, just like Quick Fix, Eclipse Quick Fix won't fix real bad semantic errors. It fixes the simple ones. Our goal is to fix the simple runtime errors, so single location errors. And the way we validate it is both Quick Fix and Defects4J have what the actual solution should be, what the actual patch should be. And that's what we're comparing, is it semantically equivalent to the actual patch.
Okay, thank you.
Yeah, more complex errors, that's not at the point where you can do it yet, even without doing it within a matter of seconds in an IDE. We do validate the ones we have, though.
Thank you.
All right, thanks. Let's move on to the next talk then. Thanks. So the next one we have from Daniel Fortunato, and the title is Mutation Testing for Quantum Programs Written in Qiskit. Qiskit. Correct me if, what is the proper name for the tool? All right, I'll leave you to let us know the proper title. Go ahead. Wait, do we have the speaker here? Maybe let's skip it to see if in the end Daniel is going to join us. But for now, maybe Marco can go as the next presentation. Do you mind? Yeah.
No problem. Just a second.
So Marco Stadler is going to present his work called Flexible Model-Driven Runtime Monitoring Support for Psychophysical Systems.
Yes, thank you very much. So, our work is called Flexible Model-Driven Runtime Monitoring Support for Cyber-Physical System. My name is Marco. I'm from Linz, Austria, and I will present this work for you. So, starting with our motivation, the design and monitoring of cyber-physical systems is a crucial task. Why is that the case? So you have hardware on the one hand and humans on the other hand, usually when working with cyber-physical systems. As you can see here, for example, in a search and rescue operation, or if you think about a factory where factory workers are working side by side with robots, for example, on a conveyor belt and so on. So in all those applications, you have specific system requirements for those applications. And so you need your cyber-physical systems to behave in a certain manner. So for example, if we stick with the UAV example, those UAVs must maintain a specific no-flight zone. So, and this can be verified using so-called constraints. So we have to check at runtime whether those constraints are maintained, whether those system requirements are met. And that is what this is all about, basically. Further, cyber-physical systems are usually running on a long-term basis, meaning they're changing over time. For example, new software updates are coming, new hardware is added or updated, changed, and so on. So if you have usually a monitoring framework that serves this application, it does not serve the evolutionized system. So off-the-shelf monitoring approaches do not co-evolve usually with the system. And this is the point where our framework comes into play. Our framework is called GRUM, which is short for Generating Runtime Monitors. And the overall goal of GRUM is to have a co-evolving framework to generate runtime monitors and check the constraints. For doing so, we developed a model-driven approach. which is basically you have some models which contains a meta model and some domain information. And then based on those models, you generate some probes, which you can imagine is basically the piece of software that collects data from the cyber-physical system and forwards it to a monitoring platform. And then it also can generate the whole monitoring platform. So the data collected from the probes gets then processed at the monitoring platform, and you can check the constraints, you can persist the data, you can visualize it, and so on and so forth. So this two parts, the probes and the monitoring platform, are generated based on the model. So you don't have to code that. Now, the huge advantage of GRUM. So GRUM can co-evolve, meaning that if your system changes, you only need to change the model. You don't need to adjust the code for the monitoring platform or the probes, etc. You just need to change the model. And then based on the model, you can just regenerate the probes and the platform. So you don't need to code there anything. Our current state is that we have evaluated GRUM using Java-based UAV system, and we used a Python-based Turtlebot 3 robots. So basically, you can now reuse GRUM for every other Java-based system and for every other Python-based system. That is really cool. For the future, we want to have adaptive monitoring, meaning depending on which state, for example, your UAV is, whether it is on the ground or whether it is flying around, you want to have or want to collect data on a different frequency, for example. And we also want to have additional evolution support, meaning that you can detect whether your system changes and automatically synchronize this with your models and then respectively regenerate GRUM components, for example. And with that, I'm at the end of the presentation, and I'm happy to answer any questions.
So how complex are the models?
I think that's kind of a question of how complex is it for you? Like, it's more of a personal thing. Well, the thing is, you have basically two parts. You have the meta model, which basically says, okay, you have a system has an agent has a property, and so on. And then you have the second stage, where there are actually the domain properties. Like, for example, then a system is a UAV system. A UAV system has a UAV, and a UAV has, for example, a battery property. So, and then you kind of map those things together, and then you just put in some more knowledge about where you want to put that information from the collected data, and that's basically it. Yeah.
That's the context. You know, how big is that? Is it 1,000 lines? Is it 100 lines? And how long does it take an expert to actually create it?
Well, it's basically very simple, because you don't need to model the whole system. So that's the point. So if you're only interested, for example, in the battery of a UAV, you only need to model this part of the system. You don't need to model the whole thing. If you're interested in the technology behind it, we're basically using EMF, so the Eclipse modeling framework, and using the eCore ecosystem. So that's basically it, yeah.
Other questions? Right. Thank you for the great talk. I think that Daniel is here. I don't know, sorry if I missed you or you just joined, but I think that the floor is yours now.
Thank you very much. Let me just share my screen here. Okay. So hi everyone. So today I'm going to present the poster on mutation testing of quantum programs written in Qiskit. My name is Daniel, and this work was done in collaboration with José Campos and Rui Abreu. So there are a lot of challenges regarding quantum testing. One of them, and probably the main one, is the qubit properties. For example, superposition that have a put the qubit in a state of 0 and 1 at the same time, so probabilistic state. So this makes it impossible to inspect a qubit mid-execution of the program. Since there is a different programming paradigm, it is also harder because it involves quantum mechanics, which not a lot of people know about, and this makes developers having a lack of knowledge in this field, and makes it harder for them to program in quantum computing. Current testing approaches are very preliminary, and more approaches and tools should be proposed for the quantum community to test quantum programs, because I think it is necessary. So mutation testing, as you well know, refers to small syntactic changes that you perform in the source code, and then when you run these syntactic changes are mutants against the test suits. If the test suit casts the changes, the mutant is killed. If not, the mutant survives. As you know, mutation testing has proven to be beneficial in improving testing practices in last years. It is used to assess the quality, the effectiveness, and efficiency of test suits. We want to bring this to quantum test suits. And the point of bringing mutation testing to the quantum world is because it can bypass some of the testing issues I previously mentioned. Because syntactic changes are performed before program execution, so it doesn't interfere with the execution of the program. So we propose the concept of syntactically equivalent gates. So gates in quantum computing are shown to be a focus of bug patterns in quantum programs. There are many types of gates: single qubit, multiple qubits, whole circuits. And we define syntactically equivalent gates as gates that take the same number and type of argument. So for example, here we have the X gate with 1 qubit and the H gate with 1 qubit, and we would say these are equivalent. This is the image of the Qiskit's equivalent gates that we built. I note that syntactically equivalent gates do not produce the same results. They're only written similarly. So we proposed 5 novel mutation operators. So quantum gate replacement, deletion and insertion, measurement, insertion, and deletion. Now I'll explain what each one of these does. So for the quantum gate replacement, we can see, for example, for a quantum gate call that it would replace with a syntactically equivalent gate. In this case, it's the H gate. There are 9 others for the X gate, for example. The quantum gate deletion, we simply remove the function called and replace it with a pass statement. And for the insertion, after each quantum gate call, we insert a new one following the quantum gate call, which is equivalent. For the measurement insertion, it's similar to the gate insertions, but instead of adding a gate call, we add a measurement call. And for the quantum measurement deletion, we simply delete the measurement from the source code and add a pass statement. So we built a QMutPy, which is a quantum mutation tool on top of MutPy, another Python mutation testing tool that has 20 classic mutation operators already. We implemented on top of those our 5 quantum mutation operators that I just described. QMutPy is open source, fully automatic, and scalable. It also produces reports that can be parsable, and to help in the mutation analysis. And is also easily extendable, so we can add more mutation operators easily. So we also did a preliminary empirical study where we considered 11 Qiskit programs that range from 80 to 400 lines of code. We managed to generate 700 mutants and killed 325, survived 307. 2 were not exercised and 62 timed out. Our quantum gate insertion and quantum gate replacement were the ones that generated the most mutants, so 300 almost each. They are almost always killed by test assertions, but the quantum measurement insertion was killed by crashes, because if we insert a measurement in the source code, as you know, the superposition collapses and we lose the value. At program level, the mutation score is close to 60%, which is not a lot, and we mutated 4 lines of code per program and 14 mutations per line. So as key takeaway messages from this poster, I would say testing is a good software engineering practice and should not be overlooked. Testing quantum programs is not easy, and there's a lot of lack of material to test them. Mutation testing can bypass the issues derived from quantum programming. And syntactically equivalent gates, as we proved, can improve test suit quality, since it can easily see the mutation score should be higher and programmers should improve it. Overall, current quantum community would benefit from tools and approaches like this to better be able to assess and correct their programs. That's it for me. If you have any questions, I'll be happy to answer. Thank you very much.
Right. Any questions from the audience?
I'll just put this here.
Yeah, I was just wondering, what are your next steps for your work here?
Next steps, we have quite a few in mind. For example, the first one, the obvious one, would be to add more mutation operators. For example, to mutate instead of the actual quantum gate, just mutate the value of the qubit and simply be able to generate more mutants and see different results, or to better adapt the test suits. Other things that I've been working on is defining a set of metamorphic rules that could be able to, because since we can't inspect the actual program and the values, we could actually just propose some metamorphic rules that create having something that doesn't actually change the value, and that way we can see if the difference is appropriate or not with the set of rules that we define for the result in the quantum program. That would be the two main things that I'd be interested in working on after this.
Okay, thank you.
Yeah.
Anyone else here have questions or feedbacks? All right. So yeah, maybe we can move on first to the last presentation for our session. And last one from Louis-Philippe. And this work is entitled Enabling End Users to Improve Larger Block-Based Programs.
Okay, can you hear me? Okay, great, thank you. So in my presentation, what we have done is we have been studying how we can enable end users to implement large programs in block-based languages. One of the problems that we face in block-based environments is that as the program grows, it starts to be more complicated to understand what is going on. If you are an end user, someone without experience in programming, it might be difficult for you to organize the code in a way that makes sense and that you can understand, especially when you have a huge amount of blocks. What we have so far, in terms of tools available that you can use to implement a block-based environment, are basically environments where you have an unstructured or a fairly structured layout, which basically means that, or you basically attach all blocks in a single workflow, or you use functions, but the functions are in the same workspace, which for an end user, someone without experience, it's hard to understand. They can't understand the relationship sometimes between like calling a method from one section and on one group of blocks to another group, and that's partially relatively complicated for them in terms of programming. So what we are doing here in this study, we are proposing a new design for block-based programming languages, where you try to create an intuitive way for end users to use functions. And the way that we do that is relatively simple. Instead of having just one canvas, we have two canvases. And in one canvas, you organize the functions, and in the other canvas, you organize the code or the blocks related to that function. In this way, we believe that it will be easier for end users to understand the workflow that they are working on. And it will also be easier for them to use functions in a more simple style, let's say. As you can see on the bottom left of my poster, I have an example of the prototype that we implemented. So we have like the left canvas just displaying the functions, and the right canvas displaying the code related to each function. So when you click in one block, you can basically see what is going on in that function. Our use case here is specific to robots. We have been working with robots, and when you have like let's say a standard block-based environment, what happens is the users starts to teach a lot of locations, and then they just get confused because they don't know what the blocks mean at the end when they increase, as the number of blocks increases. And then what we have here in this prototype is basically a way to control mobile robots. You have a block-based environment using this design pattern that I'm talking about, where you divide the code into canvases. And what we do here is to control the mobile robots. To test if this design, if this strategy is better than what we have so far, in terms of tools and layouts available, we ran an experiment with end users. We invited these users through the Amazon Turk environment, and we applied an online experiment where we asked them to solve 3 tasks related to mobile robots. So they basically had to move boxes from one workstation to another. What we have found so far when we compare the traditional way of block-based programming to our way of programming is that in both environments, in both strategies, when end users, they organize their code, they can achieve a better performance, or in other words, they can solve the tasks with a higher success rate. And we also find out that our layout is better than the traditional way of programming in block-based environments, especially when you have a large number of blocks, or in other words, a more complex task, a task that requires more blocks, in the same environment. As a future work, we plan, because we just ran these experiments online, in a website, we plan to do the same thing in a physical environment, in a real scenario. So right now in my lab, we have a mobile robot, we have 3 different workstations, and we are going to compare the same thing that we compare the traditional way of programming with this new design that we are proposing, to see if in a physical and real environment the same results apply, or not. And that's what we're going to test next. You can also scan the QR code if you want to visit our prototypes and the results that we have got so far. Thank you.
Yeah, thank you very much. Questions?
Yeah, actually, what physical robots are you targeting for your future work?
We are using basically a mobile robot and a one-armed robot at the top of it. I'm not sure if you can say it. Let me try. See right there, the mobile robot, and the mobile robot is at the bottom, and then we have a one-armed robot. And the task is basically you have to pick up cubes from one station, stack them, and in the other 2 stations, you have to pick up the cubes from one station, move them to the other. So they basically put the blocks into the robot, and then they move it to the other station. And we are basically measuring if they can solve the problem using our language or not. That's how we do it.
Okay, and what operating system are the robots using?
Well, it depends. Like we have 2 robots. So the mobile robot's a mirror. I don't remember. We have an API. We use a REST API to control the robot. And the top one is a universal robot. So we use their own language called URScript, which is similar to Python. And we implement everything in a WPF application on Windows. So it's basically C#. That's how we implement this.
Yeah, I was just wondering how you transfer this block code then real to the actual comments, because for my work, I just work with ROS, and that's quite complicated, or at least I think that's quite complicated.
Yeah, we use a library called Blockly, which provides us the block-based interface. We just manipulate it as we want, and then we basically translate these to standard code and the languages that we are using. That's how we do it.
Any other questions from the audience? Yeah, I have a question that this is kind of function styles of reuse. Do you think other kind of practice for traditional software engineering, like API design or documentation, can be borrowed somehow to support the block programming language as well?
Oh, definitely, definitely. Yeah, that's exactly what we are exploring right now, because what we have so far for these kind of robots is our languages that are, let's say, not focused on end users in general. So they are really complicated to understand, and users, like they're, for example, these robots here from ABB, the languages that they use are similar to Pascal. So, for someone of our experience, it's kind of complicated to understand. And what we are doing is basically extracting knowledge from different sources and trying to merge these in a solution that makes sense for end users. But yeah, definitely.
Yeah, thanks. Yeah, I really like how diverse the topics are within our session. So we have 8 minutes left. So yeah, the floor is open. If you have questions that you forgot to ask, or just start ringing the bell right now, you want to ask, feel free. Or if you want to just chat with others to discuss some ideas, yeah, we can also use the time.
I have just one last question to Stephen, whether they are planning on extending their approach to another language besides Java.
Sorry, we cannot hear you because you're still muted.
I'm not at this point. It's a lot of code that's very Java specific, because we have the FATE, which is the flow analysis, which works as the user types, keeps up to date, and continually does that. Yeah, that's probably 60,000 lines of code. And then there's CD, which does the live programming for Java, live programming at that. And that's another 50,000 lines of code generating the trace. And then there's Rose itself, which most of it is not Java specific, but a good chunk of it is. And that's another 40,000 lines of code or so. So you're looking at something. We did a demo that works for Java, and that's where most of the tests are. But if somebody wants to do it, I'd be happy to help them do it. But it's a lot of work.
Sounds at least like that.
You need the flow analysis to do the fault localization. You need to generate execution traces that you can compare both of their values and flow, and generating that and doing it without actually executing the program, and handling all the libraries and native code and everything else. It gets fairly complex.
You mentioned that the project itself now is open source, right? If I remember correctly. Yeah. So
all of the things are open source on GitHub.
Yeah. So anybody, if you are interested, yeah, definitely check it out and contribute.
I have a follow-up question. Like, if we want to extend Rose, like to cover more bugs or vulnerabilities, like how much effort you expected that would cost?
To cover more
other type of vulnerabilities or bugs?
Well, we can cover. It's very easy to add new methods to generate potential patches. Adding, say, you wanted to have a new, you wanted to make sure something else didn't happen. We have, variable has a wrong value, exception thrown, assertion thrown. My guess is that anything new there is about 500 lines of code. So it's understanding, it gets involved in multiple places in the system, but it's not much code. Essentially, what you need to do for the vulnerability is identify what are the local variables that are key to this at the breakpoint, and also how you validate whether the problem went away, given the trace.
Yeah. Thank you.
But those things are fairly easy to do for most vulnerabilities you want to do. We also have expression has the wrong value and things like that, which I don't mention because I don't know if it works that well. But yeah, we have adding new vulnerabilities is fairly easy. You also have to put a front end, the option in there.
It's good to hear that. Thank you.
Right. Any other comments or thoughts? So maybe I have a question for James. And when you give the presentation, you illustrate that slides among all the more than 3,000 projects. You're only able to use 7 in the end. That's quite astonishing. So moving forward, how do you consider the difficulties of data collections are going to shift the strategies a little bit, including other kind of apps like web apps or other things, or what kind of steps are you going to take?
So we have 2 approaches right now. One of them is just to write tests ourselves. But obviously that's quite a intensive process, and writing tests for Android is quite difficult. There's a lot of like hidden states, a lot of code that's needed to kind of set up the applications to get them to run in and test what you want to test. But also, yeah, we are looking into some automated test generation techniques. But again, that is also quite difficult and quite awkward. With most things in Android, yeah, there's a lot of engineering effort needs to go in to make it work with existing tools. So yeah, but I think automated test generation is probably the way to go, just because like without these tools, yeah, I suppose developers don't really seem to want to write tests for open source projects, at least for Android.
So yeah, test and documentation, those are the things. At least compared to documentation, maybe tests have a higher priority.
No, yeah. Well, all of the testing tools also have no documentation, which doesn't really help.
Yeah.
About 60% of the projects in GitHub have no tests, or in Merobase is what I looked at.
Right. That's why probably we need to be more creative and support those people who are not following up the best practice there. Okay. So yeah, I think we're almost done with the time. And thank you very much for all the great talks and presentations, and also the resources you put on the chat, and check it out if you're interested, including papers and presentations and demos, etc. And yeah, hope you enjoy the rest of the conference, ICSE, and the following up conference that is another week. And yeah, take care. See you then.
Thank you.
Thanks.
Bye.
Bye.
Bye.